So good morning everyone. I am Jerry Kuhapin. Today we are going to answer this problem. The given linear systems, which is the equation 1, 2x plus 3y minus z is equal to 0, and the second equations, which is x minus 4y plus 5z equals 0. So the question says, verify that if the x sub 1 is equal to 1, and the y sub 1 is equal to negative 1, and the z sub 1 is equal to negative 1 is a solution to the given linear system. So in order for us to verify that if this value is a solution, first thing to do is to substitute this value to the given linear system. So first, we substitute the given value to the first equations in the linear system. So the first equations are the 2x plus 3y minus z is equal to 0. So we substitute the value of our x sub 1, y sub 1, and z sub 1. So here. So 2 times 1 is equal to 2. And positive 3 times negative 1 is equal to negative 3. And then negative times negative 1 is equal to positive 1. So we put question mark in the top of equal signs because we are not yet verify if this value is a solution to the given equations or to the first equation. So 2 minus 3 is equal to negative 1. 1 plus 1 is equal to 0. So therefore, the value of our x sub 1, y sub 1, and z sub 1 is a solution to the first equations. So for us to conclude that the given value is a solution set to the given linear systems, we need also to verify the given value, or we need to substitute the given values to the second equations. So the second equations is x minus 4y plus 5z equals 0. So same as before, in order for us to verify if the given value is a solution to the given equations, we need to substitute the given value to these equations. So the value of our x sub 1 is 1, and the value of our y sub 1 is negative 1, and the value of our z sub 1 is negative 1. So copy the number 1, then negative 4 times negative 1 equals to positive 4. Uh, Copy the number 4, and positive 5 times negative 1 is equal to negative 5 equals 0. So we put question mark on the top of the equal sign because we are not yet verified this solution if this is the solution of the given equation. So 4 plus 5 is equal to 5 minus 5 is equal to 0. So therefore, the given value is a solution to the second equations. So the given value is a solution to the two equations. So therefore, the given value is a solution to the given linear system.
So good day everyone, my name is Gabriela Nicole Dipat from BS Ed Math 2. So today I will guide you through verifying a solution for a system of linear equations. So we already have the given linear system, which we have the two equations. The first equation is 2x plus 3y minus z is equal to 0. And the second equation is x minus 4y plus 5z is equal to 0. And our goal is to verify that x sub 2, these values, x sub 2 is equal to negative 2, y sub 2 is equal to positive 2, z sub 2 is equal to positive 2, is a solution or satisfy both of our equations here. Okay, so let's proceed to the next slide. So we already have a proposed solution in here. Okay, so but I will explain why and how it works step by step. So we are dealing with the following system, given equation here, right? These two equations, which is 2x plus 3y minus z is equal to 0, and x minus 4y plus 5z is equal to 0. And we need to verify that these values x sub 2, y sub 2, z sub 2 are indeed solutions to these two equations. So first thing is we need to use the first equation, this side. Okay, the first equation, the 2x plus 3y minus z is equal to 0. So we are going to substitute these values into this equation. For the x, we are going to substitute the x value, which is negative 2. So it becomes 2 times negative 2. And for the 3y, we are going to substitute the y sub 2, which is the positive 2, to this 3y, this to the y term, with which it becomes 3 times 2 minus, so our z, we are going to substitute our value of z, which is positive 2, and now it will become negative 2 here. So now we are going to simplify. So first thing is, the 2 times negative 2 is negative 4, and 3 times positive 2 is positive 6, and copy the negative 2. Again, simplify this new equation. So negative 4 plus 6 is equal to positive 2. And copy the negative 2 here. So 2 times, 2 minus 2 is equals to 0. So therefore, confirm that 0 is equal to 0. So, and the check mark there indicating that the solution satisfies the first equation. Okay? All right. So now let's proceed to our second equation. So we have our second equation here, x minus 4y plus 5z is equal to 0. So we are going, same process, we are going to substitute the values of x sub 2, y sub 2, and z sub 2, okay, into this equation. For our x, we have negative 2. So our x here is negative 2, so it becomes negative 2 here. The x, it becomes negative 2. And for our y is positive 2, so it becomes negative 4 times positive 2. And for our z is positive 2, so it becomes 5 times 2. So now let's simplify. So first thing is to simplify this one, the negative 4 times 2. So negative 4 times 2 is, yes, negative 8. And positive 5 times 2 is equal to positive 10. Copy the negative 2. And now let's simplify this new equation. Negative 2 minus 8 is equal to, okay, very good, negative 10. And copy the positive 10. So adding them is equal to 0. So confirm that this is also equal. 0 is equal to 0. And the check mark there verify that the solution, these values are the solution or satisfies the second equation as well. So since both of the equations are satisfied with the given values, x sub 2 is equal to negative 2, y sub 2 is equal to positive 2, and z sub 2 is equal to positive 2 are indeed solutions. They are the solutions to our system. Okay? So this is justified by the calculations and checks we have performed. Okay, so thank you for watching. I hope this explanation helps you to understand how to verify solutions for your linear systems effectively.
So for now, we have letter C. So is x is equals to x sub 1 plus x sub 2 is equals to negative 1. Y is equals to y sub 1 plus y sub 2 is equals to 1. And z is equals to z sub 1 plus z sub 2 is equals to 1, a solution to the linear system. So here is our solution. So as we can see, we have already a values of x sub 1, x sub 2, y sub 1, y sub 2, and z sub 1 and z sub 2. So let us find if x is equals to x sub 1 plus x sub 2 is equals to negative 1. So we have x is equals to x sub 1 minus x sub 2 is equals to negative 1. So we are going to substitute the value of x sub of our x sub 1 and x sub 2. So we have x is equals to 1 plus negative 2 is equals to negative 1. So since 1 plus negative 2 is equals to negative 1, so we have x is equals to negative 1 and is equals to negative 1. So they are equal. Next is we are going to find if our y is equals to y sub 1 plus y sub 2 will equal into 1. So we have y is equals to y plus y sub 1 plus y sub 2 is equals to 1. So since the value of our y sub 1 is negative 1 and y sub 2 is positive 2, so we're going to substitute. So we have y is equals to negative 1 plus 2 is equals to 1. So we have y is equals to 1 is equals to 1. So they are equal. Next is we are going to find if z is equals to z sub 1 plus z sub 2 will equal to 1. So we have z is equals to z sub 1 plus z sub 2 is equals to 1. So we are going to substitute the value of our z sub 1 and z sub 2. Now we have z is equals to negative 1 plus 2 is equals to 1. So since negative 1 plus 2 is 1, so we have z is equals to 1 and is equals to 1. So they are also equal. So therefore, the value of therefore the statement letter C is a solution to the linear system.
Now let's proceed to letter D. So is 3x, 3y, 3z, where x, y, and z are as in part C, a solution to the linear system? So from our part C, we obtain the solutions which are negative 1, 1, and 1, wherein our x is negative 1, our y is 1, and z equals 1. So next is we are going to multiply each component by 3 since we are given 3x, 3y, and 3z. So we are going to substitute the value of our x, y, and z. So 3x will become negative 3 since the value of our x is negative 1. So 3 times negative 1, that is negative 3. The same as with our 3y. So 3y equals 3 times 1, that is 3. Or 3z equals 3 times 1 equals 3 also. So now we have to verify if negative 3, 3, 3 is a solution to our linear system. Okay, so let's start with our first equation. 2x plus 3y minus z equals 0. So we are going to substitute the values of our x, y, and z. So this will become 2 times negative 3 plus 3 times 3 minus 3 equals 0. So 2 times negative 3, that is negative 6, plus 3 times 3, that is positive 9, and then minus z equals, or minus 3 equals 0. So negative 6 plus 9 minus 3, that will become 0. So 0 equals 0, which means it is true that negative 3, 3, and 3 are solution to the given equation. Now let's verify if it is true on the second equation. So x minus 4y plus 5z equals 0. So again, let us substitute the value of our x, y, and z. So our x is negative 3 minus 4 times 3, which is the value of our y, plus 5 times 3, which is also the value of our z, equals 0. So negative 3 minus 12, since negative 4 times 3, that is negative 12, plus 5 times 3, that is 15, equals 0. So the answer is 0 equals 0, which means that negative 3, 3, and 3 are the solution of our second equation. So this means that 3x, 3y, 3z, or negative 3, 3, 3 is a solution to the given linear systems.